Hi, and I would like to welcome you all in this second hour of the conference during the International Day of Clean Energy that is organized by Kuwait Society of Engineers that hosting and organizing this conference with the participations of our esteemed speakers. Now we will start with the fourth speaker, Mr. Antonio Campos. He is CEO of the Hub to Energy company, and he is a president of Portuguese Business Council in Kuwait. Mr. Antonio, you can start, please.
Thank you, Engineer Salam. It's my pleasure to be here and to share the screen with so many distinguished speakers and attendees. First, I would like to thank the Kuwait Society of Engineers for the invitation and to celebrate this very special occasion, the first International Day of Clean Energy. In this regard, I want to pay tribute to the Kuwait Society of Engineers to put one more time Kuwait leading actions for sustainability. But today is a very special occasion, I will say, for three main reasons. One, raise awareness, precisely through important events such this day and this event here. It creates a platform for global public to raise awareness on the importance of clean energy in addressing global challenges such climate change, low carbon emissions, sustainable solutions, achieving net zero targets, promote the UN Sustainable Development Goals. Clean energy is close tied to several sustainable development goals. These goals include affordable and clean energy, climate action, and the promotion of sustainable cities and communities. But in general, is all the sustainable goals that we are talking about when we are talking about clean energy. Advocate policy and action. Governments, policymakers, international organizations, universities, the private sector, we can use this occasion to emphasize the importance of creating and implementing supportive policies, regulations, and incentives that encourage the development and the deployment of clean energy technologies and solutions. On the energy, for sure, or when we are talking about energy, for sure, we have a lot of opinions. But one thing we can all agree on is that we need more energy in the decades to come. And in this regard, we also need all energy approaches. For example, in the last year, fossil fuels represented 78% of the total consumption of global energy. But what we can do is try to apply clean energy principles to this industry in the attempt to decarbonize and reduce the impact, and in the other hand, increase the renewable energy sources. As Mr. Tarek said just before, the mix of the energies is a key.
Yeah, the slide is not moving, Mr. Antonio. Yeah.
So let's have a look on the history of the energy transitions. Is it okay now? I don't know, it moves or not?
Yes, we see the graph.
Yeah. So let's have a look on the briefly on the history of the energy transitions. When we talk about clean energy, this concept isn't new. In fact, humans have been transitioning in the energy landscape for at least 200 years. Before the Industrial Revolution, societies primarily rely on the traditional biomasses. This period was characterized by decentralized and largely sustainable energy uses. But the Industrial Revolution in the 19th century marked a major transition as coal became the dominant source of energy for steam engines, industrial process, and later electricity generation. This era saw the rise of centralized power productions and significant social and economic changes. The discovery and utilization of the oil and the natural gas expand the energy landscape. These fossil fuels became and still are crucial for transportation, industry, and electricity generation, leading to increased urbanization and globalization. After, on the turn of the millennium, growing awareness of environmental issues and the need to reduce the greenhouse gas emissions has raised the interest in the renewable energy sources, such as solar, wind, hydropower, geothermal. Advances in the technology, declining costs, and policy incentives have contributed to increase the integration of the renewable energies into the energy mix as we know nowadays. All this legacy brought us here, and here we are, 2024, celebrating for the first time the clean energy. But what is the energy source for clean energy? Clean energy, it doesn't come from any source. Maybe sounds strange, but clean energy, it comes from the knowledge that we got from all this time until now. And nowadays, everyone is speaking or talking about AI and artificial intelligence, in my opinion, or AI, artificial intelligence, of course, it will be important, they will have an important role, but AI for me is accelerate the intelligence, is accelerate the knowledge, is accelerate the transitions. So we arrive here accelerating transitions. This is the clean energy age. As we are in the event organized by the engineers, I bring the formula of acceleration and a new narrative for the energy transitions. Let's take this concept in the context of the energy transitions. I create this narrative that encapsulates the urgency and the dynamism of shifts to a more inclusive and diversified energy matrix. Let's consider this formula. Change in velocity reflects the shift from a world reliant on the fossil fuels to one embracing a broader mix of energy sources, including the renewables. Every innovation and policy that reduce carbon footprint and increase our reliance on cleaner energy contributes to this change in the velocity. We have also carbon capture, utilization, and storage, hydrogen, as we already mentioned on the first presentation, PV, cavitation, battery storage, smart grids. All these are part from this change in the velocity. The time, the age, is the equation, is the current era, is where we are now. A period of transformation where every moment counts. We are part of the age of clean all energies, a term that acknowledges the need of diverse energy sources to meet a global demand sustainability. And here we must, sometimes we hear that we don't have time, or we need to have time. If we don't have time, our acceleration is zero. We don't reach any place. We have to have time to new skills, to create new jobs. We have time to research and development. We have time to educate. And we have acceleration. Here, acceleration is our collective progress in these energy transitions. It's how quickly we can move from our current state to a future where clean and diversified energy solutions are the norm. Taking the formula in consideration, we need energy. We need all energies. But acceleration is also a vector. And as a vector, we need to have a direction. And sometimes it looks complicated. Many paths, one pushing for one kind of source of energy, others pushing for others. We need, as said before, all. And the transition to clean energy, I will say that is like solving a Rubik's Cube, where each twist affects the other. It's a puzzle of technology, finance, policy, and human behavior. But the good news is, just like in a Rubik's Cube, there's a solution that demands from our side innovation, collaboration, and determination. And this is our direction. So let's have a small look on these three twists that I choose to achieve this direction. Financing investment. We spoke before that financial is the backbone of the sustainability. Over the last decades, the level of investments in clean energy, let me just share this graphic. In 2017, we have the clean energy and fossil fuels investments almost in the same level. Last year, we almost duplicated the levels or the investments on the green energy. This is mandatory. This is crucial for our path to a clean energy. This is where development and investing banks can play a major role. They need to provide more support to financing at preferential rates, if possible, establishing a framework that would guarantee more safety and stable clean energy investors.
Mr. Antonio, we have 1 minute.
1 minute. I will just quick go for the policy. The policy, we spoke about the policy that we need the policy. Policy is another key in our transitions for the global cooperation. Mr. Tarek spoke about the PPP projects is a way for the governments and the private sector get engaged. We also spoke about the collaboration between countries, the getting the expertise. I will say that energy doesn't have borders. So we need to look to the challenge that we have had from land uses, cybersecurity, grids integrations, and also to look for the opportunities that we have. And on this global cooperation, on the energy projects, on ACGs, on educational, I will put the focus on the educational and the getting new skills, new opportunities. And thank you. And thank you. And after we can, we could be here talking for hours about the about our path to accelerate the energies.
Right. Thank you, Mr. Antonio. You gave like hints and flashing for how to accelerate the energy transitions. I think we'll have some questions after, the at the end, inshallah. Thank you, and we'll move to our fourth speaker. Now, Dr. Raed Bkayrat, he is Energy Transition Executive and net zero carbon advisor. Dr. Raed, you can start, please.
Good evening, everyone. Assalamu alaikum. First of all, I would like to thank Engineer Salem for his efforts and initiatives, always very positive in helping spreading the word and knowledge sharing and increasing the participation in our important field. And I want to thank the audience and the speakers for their participation as well. I would like to take the next few minutes really to dive into a little bit of what's happening in our region, mainly when it comes to climate change and net zero carbon targets in MENA. As you all know, I mean, the impact of climate change has been very significant and is accelerating in many ways. You can see the frequencies and the values of cyclones, of droughts, of dust storms, what have you, increasing over the last few years, and you can see a difference from year on year. Our region, we have the impact of increasing sea levels. You have cities in North Africa like Alexandria and others that are threatened by it directly. And we have, erosion of land that is available for agriculture and so on. And if you look at the issue of global warming, today, I think everybody agrees we crossed the average temperature rise of 1 degree. And depending on the studies that you can refer to, whether be it based on current pledges and targets or current policies and what do we need to do, on our current path, we will exceed the limit set by the Paris Agreement in COP. We will exceed the ceiling of 2 degree temperature rise. Our target is 1.5 degree temperature rise. Our current path easily takes us to 3 degrees and beyond by the end of the century, which is obviously a huge topic, if not addressed sooner than later. There is the concept of carbon budget. How much carbon are we able to continue emitting before we exceed the 2 degree rise? Some studies say it's in by 2041. Somebody say a little bit sooner or later, but we're on path to depleting our carbon budget, if you will, that we're allowed to emit. And in our region, unfortunately, I would say we have a more severe impact. Global temperature rise of 3 degrees means 5 to 6 degrees temperature rise in our region. In the GCC, it's expected that summer temperatures will hit 60 degrees for prolonged hours and prolonged weeks. And you can imagine the impact on the grid, on the quality of living, and the adaptation and the resilience that is needed to be added to the infrastructure. So this is just a highlight of what is happening. And this is I call it a new reality that we have to adapt to and we have to address sooner than later. And as you all know, Secretary Guterres had an announcement a while back addressing this point and the fact that, the the longer we prolong our action, the more severe our actions need to be. I mean, the investments needed today, it's in the range of less than 400 billion on renewables annually, globally. That has to be accelerated, which means double or triple the investments and triple the size of projects that are being installed as we move forward towards 2030. In terms of a global status, if you look at the total final energy consumption, and this is a good map to understand where are we emitting emissions that are harming the environment. If you look at heating and cooling, it's actually 50%, 51% of our total energy consumption. This is the energy that is consumed at the consumer side, not excluding the generation and losses in transmission. And out of that, about 11% is driven by clean energy, such as solar thermal and so on, heat pumps, what have you. Transportation emits 30% roughly, and we have a good penetration of EVs that hopefully, electrified or powered by clean energy. The power sector itself is less than 20%. And this is an important point. I mean, out of that, we have close to 30% already an increase of renewables. And in the region, we're very proud, as we should be, of the large utility scale projects. Now it's very standard to see a utility scale project of 1.5, 1.7 gigawatts, single PPA being tendered and achieving a tariff of 1.5 cent US per kilowatt hour. But all this really helps decarbonize roughly 17 to 20% of our total emissions. When you think about that, we have a long way to go to achieve our net zero carbon targets. And few highlights on this. If you look at global CO2 emissions, then energy is related to only 3/4 of that. And the rest you can talk about land use, sheep, agricultural, cows, and so on. Modern renewables account for 12.6, roughly 13%. The number is likely higher now of final energy consumption. Annual investments number hasn't changed much, between 370 billion to 400 billion, depending how you calculate it. In terms of net zero carbon targets, we have 135 countries already announced of some form of net zero carbon target, and these countries account in general for 88% of global emission. So the intent is there, the political will is there, but I think we have to work together to provide the finance and the technology and the proper regulatory framework to achieve that. Fuel subsidies continued, around 6 trillion USD of subsidies on fossil industry. Roughly 11 million per minute is provided to the fossil fuel industry as a subsidy, either as tax credits or as subsidized fuels that are offered in local markets, just as happening in the GCC countries, although countries in GCC are moving away from subsidizing local consumption, and so on. So one of the main points that I think needs to be addressed when you talk about the motivation for the private sector to decarbonize, other than the goodwill for the environment and the local society, and other than trying to optimize their bottom line through initiatives that help reduce OPEX and provide a better quality of work for the employees and so on, there are global initiatives that are very, very effective and could be very impactful to industries, especially in our region. The most significant one, I would say, the foremost one, is the one that the EU has launched, they're called CBAM. CBAM is the Carbon Border Adjustment Mechanism. So basically, the EU has very strict, if you look at the Green Deal and the regulations for carbon emissions on industry, the EU has set strict standards for products that are made in the EU in terms of achieving very low embedded carbon in these products. And the fear there is that companies would migrate outside the EU to countries that have or don't have the same strict conditions, and then export those products back to the EU, and so-called carbon leakage or carbon migrations. So what is happening, the EU has already signed the legislation that came into effect actually in October 2023, whereby any product that is being exported to the EU or imported by a company or an entity inside the EU has to meet certain metrics when it comes to embedded carbon in this product. Now, the system came into place, the regulation came into place in the end of 2023, and the first report is due by the end of this month, actually, in a couple of days. This would be the first report that is provided under the CBAM mechanism for anyone exporting products to the EU or importing products from outside the EU to the European markets. And it's done on voluntary basis right now. There are clear formulas and, if you want, processes on how to define, how to disclose, how to calculate the embedded carbon in these products. And this requirement, the CBAM requirement, will be definitive. It will be compulsory by January 2026, whereby these goods that are brought into the EU, the people behind them have to buy the so-called CBAM certificates. And if the product does not meet the embedded carbon of products that are made inside the EU, then they would have to pay for these CBAM certificates on a price range that is comparable to what European manufacturers would pay for their carbon tax. And the sectors that are targeted initially are as you can imagine, the energy-intense sectors such as aluminum, steel, fertilizers, electricity. If you want to export electricity to the European Union, you would have to abide by the same regulations for local power generators, cement, hydrogen as well. I think there were a couple of discussions on hydrogen and green hydrogen, of course, and the need to minimize the carbon footprint in that. And we've seen, US regulations that defines different levels of credit based on the carbon footprint of the hydrogen, requirement for temporal correlation, co-location, and additionality of renewables as a power source. So GCC companies that do business in the EU, to put it short, are mandated now to take CBAM into consideration and to begin to decarbonize their products and their operations to be able to be competitive in the European market. Else they would be basically losing edge, and it would be too expensive for them to export their products into the EU. Now, in terms of funding, and I think it's always important to reflect on that, depending on the current plans, announced plans in terms of targets and pledges, current scenarios. This is from IRENA. We're looking at roughly $95 trillion US dollars are going to be spent between now and 2050 on different sectors that range from electrification, grid infrastructure development, renewables, energy efficiency, and even the oil and gas industry. And if we are to really hit a 2-degree rise and do the so-called deeper decarbonization, then we would need easily $130 trillion. And I think these values have been calculated roughly now a year or 2 years ago. And if you look at the numbers now, and we're in 2024, probably the number is closer to 150 trillion to be able to, invest and accelerate projects that are aiming at decarbonizing the different sectors from renewables, energy efficiency, electrification, transportation, and even the oil and gas industry. Oil and gas industry is obviously an important role in the economic development globally, not just in the Middle East. And they play an important role in helping to decarbonize. And they have a strong role to play in the energy transition as well. And in the Arab world, I think it's important to note, as I mentioned, I shouldn't say all, most of the decarbonization taking place in the Arab world aims at power generation. These are the big projects you see in solar and wind in Saudi Arabia, UAE, Oman, now Kuwait, of course, Jordan, Egypt, Morocco, and so on. And most of the investments, actually, 45% goes into the energy and transport sector. Water and agriculture sectors, they only receive 20 to 22% of the investments. And in terms of funds needed, if you look at just take major countries like Morocco, Iraq, and Egypt to account for energy transition, for them to be able to hit their net zero carbon targets by 2050, we're looking at 425 billion USD of investments that are needed. And obviously, these investments cannot be just locally, and they definitely cannot be supported by the government. They would have to be provided by the private sector and international partners. And for that to happen, obviously, we need to provide the healthy and safe business environment and clear regulatory framework that would incentivize people to invest in projects in the Middle East. I think we see that, and we see the good examples of that in the UAE and Saudi Arabia and elsewhere.
Yeah, Dr. Raed, we have 1 minute, huh?
Sure. In terms of net zero carbon targets, as you know, we had COP 27 and 28, and we had significant outcomes that hopefully will translate into action from these COPs. In the Middle East, we have countries that took initiative to declare net zero carbon targets: United Arab Emirates, Oman, Bahrain, and Saudi Arabia. Bahrain and Saudi Arabia, albeit by 2060. UAE was the first to announce net zero carbon target by 2050. And in terms of, across the region, you have Tunisia, Turkey, that has in place a policy document that sets net zero carbon target by 2050. We have countries that declared a net zero carbon target but yet to be acted into policy, such as Kuwait. We hope that the map will continue to take colors in terms of announcing net zero carbon target and setting the motivation for the industry, defining the roadmap leading to 2050. And it's important when we set targets, obviously, by 2050 to take interim targets in 2030. And this is what we have seen actually happening in the private sector. We have oil and gas companies, ADNOC, Aramco, announcing net zero carbon targets, ADNOC as soon as 2045. And they all announced interim targets by 2030. Aramco, the biggest oil and gas company in the region globally, they have a net zero carbon target by 2050, although the country has 2060 target, and they define scope 1 and 2. Scope 1, on-site direct, scope 2, off-site direct, to reduce carbon. We have Aldar, real estate developers, Majid Al Futtaim, Aqua Power, others obviously that have already announced and have taken steps actually to define their carbon footprint and to lead into the decarbonization. So this is a brief overview of what's happening in the region. I hope there was some value there, and I give it back to you, Dr. Jir Salam. Thank you.
Thank you, Dr. Raed, for this overview of net zero carbon plan in MENA region. It's quite interesting, and I think we'll have some questions at the end. Thank you again, Dr. Raed. Now we'll move to our dear friend, Ms. Sandra Baer. She is a CEO and a Personal Cities Brand Ambassador and at Smart Cities World. Also, she is Chief Smart Cities Urban Icon International. Ms. Sandra, you can start your presentation.
Thank you, Salam. Gee, what a pleasure to be here. And special thanks to the Kuwait Society of Engineers. As Salam is well aware, and I hope the rest of the audience is listening and on this call, I am not an engineer, but I am really experienced in working with smart cities for over 20 years. And so I really wanted to focus, as Salam requested, on what some of the cities around the world are doing to create clean energy. So it's a story not based on specific statistics and numbers, but more based on the leadership of what's going on in cities. In my opinion, it is the key to creating renewable energy, clean energy in cities around the world, both from government and from the private sector. So this, to me, is where the action is. And I do believe that there is a renewed interest in what's going on with cities around the world, primarily because of extreme weather events that are waking people up and helping them understand, this is happening. Sea level rise, all kinds of flooding, and as I say, extreme weather. These are factors that are making people understand action is urgent today. Salam, can you show my slides? Is it happening?
Yeah, no, I'll open it now, yeah.
All right, great. Thank
Yeah.
you. Thank you so much.
Okay, yeah. There you go.
Thank you. I really wanted to just start with some ideas. Next slide, please. With some ideas about what defines a clean energy city today. And I don't say that for the audience on this call, but more for people around the world, that most smart cities today, and I define a smart city as one that is aligned and one that uses technology as an enabler to a better quality of life. Most smart cities today are focused on the ambitious target of 100% clean electricity by 35 and 100% clean energy by 2050. As we just heard from Dr. Bayat's presentation a minute ago, not every city is in line with that 2050 goal, but in general, people are seeing the need for faster action. Investments in solar, wind, hydropower, hydrogen power, oceans, geothermal, bioenergy, all of these things are transforming the clean energy industry to generate, I think, lucrative economic activity, as we have also seen this morning, and really to help lighten that carbon footprint that we are hosting around the world. Next slide, yeah. And I do want people to understand the benefits that are occurring from investments in clean energy. And it seems like almost completely apparent, but the cost of renewable energy is lower and much less volatile than the cost of fossil fuels, and especially creating that infrastructure. So I think that's sort of a predominant factor for the private sector to take note and say, this is the way it should be. Clean energy alternatives are also reducing air pollution and related health issues, especially around low income communities. And I can't emphasize this enough. If you live near a coal plant, if you live near waste and recycling plants, sometimes that air pollution, ground pollution in and of itself is dangerous to your health. So clean energy alternatives completely do away with most of that problem. And of course, climate-friendly investments are better job creators. There's a lot of statistics around that today, especially, for example, investments in solar, investments in building efficiency, certainly creating more mass transit. I mean, it evidently creates 1 to 2 times as many jobs over investments in unsustainable infrastructure. And I think this is, we need to understand this. I just show this chart briefly to show you some of the top US cities for clean energy. I'm going to talk about one of those actually, but we're working toward a clean energy environment. We are far from it in the United States, in my opinion, and it's very important that we learn from other parts of the world, especially the Arab world and what's going on in Kuwait and other parts of MENA. Next slide, please. By the way, I'm sitting in Washington, D.C. I could have talked about my home city of Washington, But I wanted to mention a couple other cities that you may not understand or have heard about what they're doing for clean energy investments. But Honolulu in the state of Hawaii in the United States is using the abundance of their renewable energy. Lots of sun, lots of wind, hydro and ocean energy. They're doing a lot to become 100% renewable by 2045. So they're very lucky, in my opinion, to have the use of nature to create a better self-sufficiency. I also wanted to mention Reykjavik. If you travel around the world, you know that Reykjavik is famous not only for what they're doing with clean energy, but also what they're doing innovation-wise around the world. Everything that Reykjavik does is now gaining attention among smart cities. Their electricity is generated with hydroelectric power all across Reykjavik. So this is a big deal that they already have a step up from many cities that can't do that. They're also using geothermal energy and district heating, which certainly creates no greenhouse emissions. So I think Reykjavik is another good example of actually involving the community, creating more bicycle paths, getting more people to be on a bicycle instead of in a car, creating a more walkable city. That's certainly something that a lot of cities are doing. They understand how to get cars off the road, and so they're taking action. Next slide. Here's another U.S. city, Minneapolis, Minnesota, in a very used to be cold part of the United States. Today, they are really, their biggest threat is high heat. And it's sort of an irony. I know in Kuwait you have plenty of high heat during certain months of the year. But for these cities that have never experienced it, as you can see in the slide, they're expected to increase high heat days to almost 14 more than they have today. So how they're dealing with the community, how they're protecting citizens that aren't used to that kind of heat. This is what you're seeing in a lot of cities around the world. In fact, Salam, there's a push now to create their chief heat officers, because cities around the world are figuring out how to deal with this unprecedented heat. And finally, I wanted to mention Singapore, because they too are experiencing and anticipating much warmer climate, more intense storms, rising sea levels. I mean, they have crafted a resilience framework that is very worth looking at when you have a chance. And it encompasses all these areas of action, protecting coastlines with hard structures, managing water resources to prevent floods, safeguarding biodiversity and green spaces. This is what's happening in smart cities around the world. So next slide. I just wanted to mention a couple other things that I think are really relevant to what cities are doing around the world. First of all, as I mentioned earlier, it is about leadership. And I just came from COP28 in Dubai. You can see the countries, the cities, the corporations that are taking a leadership role to generate action. And I think this meeting, Salam, that you've pulled together is really reflective of worldwide attention. Another factor that's really important, in my opinion, is our ability to trust. As most of you know, many of the pledges, the promises made in COP meetings and in other climate action meetings, the promises haven't been kept. So I guess this meeting is sort of a kickoff, if you will, the first International Clean Energy Day, to really help us figure out how to trust one another. I'm actually writing a book on that topic, so I'll send it to this group when it is released. And finally, I wanted to say one final thing about involving youth. They have the burden of what older generations have done to create problems in our climate. And for any work that you're doing in engineering or technology or any kind of smart city work, I recommend that you reach out to the youth and have them collaborate with you. I work with a lot of younger people that are creating innovative solutions for cities. And I'm telling you, it's also where the action is. So Salam, thank you so much for this chance to be a part of this meeting. an esteemed set of engineers and very smart experts on climate. I wish all of you the best. Thank you.
Thank you. It's our pleasure to have you, Ms. Sandra, to show us some good example about some cities they are already achieving the net carbon or zero carbon also. And we have in GCC, there are some initiatives and some examples they started, like Masdar City. Maybe you hear about
Yes.
it. Arab. They announced about it long time ago, and they are moving in parallel, achieving and solving the challenges. They are
Yes, for sure. Masdar is a great example. I almost put them on my list, but I thought most of you might be familiar with it. But just one other thing, Salim, Smart Cities World is hosting a Cities Climate Action Summit in June of this year, and you are officially invited. We will have, I hope, Masdar people speaking about the climate actions they are taking, which are quite impressive. So thank you.
Thank you, and that's a great. It's our pleasure, Mr. Sandra, and I think we'll have some questions at the end. We'll be happy to have you with us also.
Wonderful. Thank you.
And we'll move to our next speakers, Dr. Mohammad Zamri. He is a senior scientist and he is a smart grid project lead at Qatar Environment and Energy Research Environment and Energy Research Institute, the GIRI. Dr. Mohammed, you can start your presentation. Are you there? Yes. Hi, Dr. Mohammed. You can move the. Okay.
Yeah, I cannot move now.
Yeah.
Hi, Engineer Salim.
Yeah, it's our pleasure to have you, Dr. Mohammed, as a senior scientist and also a smart grid project lead at Qatar. It's our pleasure to have you with us in this webinar. You can start your presentations here.
Thank you very much, Engineer Salim, for the introduction. And thank you for all participants. I'm pleasure to be here and honored to be among the great speaker. And I'm going to be more technical because I'm from technical background. So I'm working on facilitating the integration of renewable energy to the power grid. So this is something I'm not sure how to disable this, but I will proceed
yeah, it's fine
with my presentation. So I'm from Kerry. So quickly to introduce, Kerry is a part of Hamad bin Khalifa University. It's a national research institute tasked to support Qatar in addressing grand challenges related to energy, water, and environment. And we aspire to be a leading national and global hub for research, development, and also innovation in energy, water, and environment sciences within arid region. So we are part of Qatar Foundation. And this is a just overview what we are doing in Smart Grid. So we currently focus on three main topics: smart grid, smart microgrid control solution, and then intelligent distribution and transmission network management, and also energy storage analysis and management. And you can see the sub activities within each of these main topic. And the aim of the research is to deliver monitoring and control solution that will optimize solar PV use and ensure power stability at the national grid level, and also to optimize solar PV use and ensure power stability in local power system, especially microgrid, and also use a battery and hydrogen storage to support objective number 1 and 2 to integrate solar PV energy in Qatar power system. And we are going to integrate the hydrogen activities within this research at KERI. And yeah, the main topic today is on PMU. PMU stands for Phasor Measurement Unit. It's actually, for those who are not familiar, PMU is an advanced SCADA system. So it will offer many benefits to power system management. And if we compare between PMU and SCADA, we can see in terms of measurement, SCADA is analog, PMU is digital, and the resolution is higher. With SCADA, it's only 2 or 4 samples per cycle, but with PMU, up to 60 samples per cycle. So, of course, it can observe the dynamic and transient event within the power system. And also, there is a time stamp to each signal, each measurement signal. And also, PMU also measure the phasor angle. This is something that is not cannot be done with SCADA. So in terms of application and benefit, we can see on the right. So with PMU, we will have real-time capabilities for many things to increase system stability, to increase asset utilization and power system efficiency, for example, and also to increase organizational efficiency. And also in terms of study mode and planning capabilities, PMU also offer advantage compared to conventional SCADA. So I will not be going to very technical to scientific. I just cover the main very high level information. So this is the project of PMU that we recently completed. We managed to install. We completed installation of 10 PMUs at medium voltage 11 kV at together with Kahrama. Kahrama is a Qatar network operator in Qatar. And also this PMU is installed within Qatar Foundation's Education City, which is also considered smart city. So we work together with Qatar Foundation Facility Management and also Qatar Foundation City Operation. So we installed this at 11 kV level to the switch gear. And Kahrama only authorized OEM, which is Tamco Switchgear Malaysia, to do the installation. So we have to engage Tamco. And now we already completed in December all the installation. We started to get real-time data from all this PMU. And for the first stage, we are trying to demonstrate real-time monitoring and also fault management. So the device, you can see this is the device. There is a synchro sense, the box, and then GPS antenna, 4G antenna, current sensor, and voltage sensors. So yeah, the project is very long. The installation process was very long. We started talking since even before 2019, and then we started have a joint visit to the substation in 2019, and then try to get approval from Kahrama because Kahrama doesn't want to interrupt their operation. So we must make sure that this installation will not impact the operation and also the reliability of substation. So we have to convince them through a series of meetings, through series of demonstration, and finally they approved for the installation. And we only managed to start in 2023. And yeah, there were many problems we were facing, including COVID. So some engineer from Malaysia cannot travel, and also and then after COVID, we have a World Cup in Qatar. So Kahrama didn't want to interrupt the operation and ask us to wait until the World Cup is over. So that's why what caused a lot of delay. And this is how we install these PMU sensors PMU device and sensors to the 11 kV switchgear. 4G and GPS antenna is installed on the roof. SynchroSense is installed on the wall, mounted to the wall. Our current sensor is installed to the cable within the switchgear itself, and also the voltage sensor is also installed within the switchgear itself. And of course, to do this installation, the substation has to be shut down. So that's what also causing delay, because to find the right time to have shutdown. And this is the example of what we are getting from PMU. So we have a current in real time and also voltage. And from 10 locations that we measure, we definitely have the data. And then even though the whole network has 20 substations, but from the data from 10 of measurement, we can estimate the other location. So we actually have complete observability of the network. And we can see the voltage profile, and of course with renewable energy, we expecting the very fast dynamic. So we can see sometimes if there is voltage limit violation, and also we can see the power flow congestion, and also if there is outage, we can immediately see where is the outage is. And just to confirm why we choose fault management in medium voltage as a first stage for demonstration, because for those who are familiar, locating the fault, especially in medium voltage, which are mostly underground, is a very long process, or very difficult process, or long, very long. And in 11 kV, there is no communication. So the only way utility knows there is if there is blackout when somebody called. So they said their house has no electricity, then the team will be dispatched, and the dispatch normally they have to bring a lot of equipment, and this is most of the modern vehicle that has a lot of equipment inside from Bauer GmbH, and they have to go and check the substation. They try to switch back if the trip is happening again. That means cable, there is a fault in cable. So they have to locate by injecting, by going inside the substation and then doing analysis, and then they have to locate where the fault is using other device. And then when they find the location, they have to check which cable is actually experience fault or damage. So it's a very long process, and it also costs money, because the team normally they will move in team, even though when the team is deployed, a few vehicle will go with a number of staff. So it is also very costly, and they normally they will do the work at night, because something that the technician sometimes, even though they found the fault earlier, but they try to shift until night, because at night they can claim overtime. So the process will become very costly. And with PMU, the how to locate the fault will be easier, because the system will alert the utility immediately. And from the measurement previously, the exact location of fault can be pinpointed by energy management system. So so I'm going, only a few minutes left for me, so I'm going to be very fast. So this is what actually we are trying to do. So after the installation, we're going to feed all this real data to the digital twin. We are building digital twin in the lab, and we try to operate the power system operation in real time, and also try to use solar forecast and load forecast to and try to run to predict, to do the prediction of the potential threat to the operation in the next 15 minutes, for example, or 1 hour. So and also we are developing module using AI. So we integrate AI into the module, and also we try to do a real-time power system analysis, and with the intention it will alert the control center for distribution to minimize the threat in the operation. And this is in the lab. We already started even before we start the installation. We develop many modules for real-time control and real-time protection, and we already managed to come up with a few patents, and we managed to secure technology development fund, and we filing another patent in 2023, and we have a potential to generate more IPs. And on the right, you can see this is the setup in the lab. We have real-time platform here and real-time simulator here. And in summary, Kerry is actually conducting cutting-edge research in smart grid area, and we also have advanced research facility especially in for the PMU, and probably so far we probably the first doing the first installation in this region at medium voltage network. But for those who knows if there is an installation somewhere, please share the information. And also Kerry is also willing to share expertise and experience in this field for those who would like. And also we always open to collaboration. And this is to show the facility that we have. In addition to the lab, we also has what we call outdoor testing facility. We have a different technology of PV like CPV, linear freshness CSP, energy storage, and also different type of PV panel with edges, with edges tracker, with fixing. And also we have one section that we operate as a microgrid. And our microgrid is actually was featured last year in Homo Microgrid News. You can find more information in this article. So with that, thank you very much again to Engineer Salim for inviting me. Yeah, back to you.
Thank you, Dr. Mohammed. I'm really amazed with the PMU and how many advantages they have against SCADA. I hope your project will be succeeded, and I think all the GCC countries, I think they need to get benefit of this tools and devices that you already make up. Thank you, Dr. Mohammed, and I hope you can stay with us for the discussion panel, Bedna. Now, I think before we move to Dr. Simon, I think this is the second hour. This is the end of the second hour of the conference. We just stop the recording.